So we are given this exercise where we are asked to determine VDS, VGS, and VDG. We know that VG is located right here at this point. VG is located right here, and VS is located right here in the source. So the voltage VGS, remember that we said this first letter is going to indicate which is the positive, and the second is going to indicate which is the negative. What we are saying is that we are taking our multimeter and we are placing or trying to find the voltage from gate to source. So we're placing the positive here and the negative here. And to determine the voltage VG, we are putting the positive lead here and the negative right here. So the voltage VG, saying this is positive and this is negative right here. And we also want to get a little bit crowdy. The voltage from here to here, which is the voltage VDS. There's a couple of ways you could do this. I'm gonna try first with KVLs, 3 KVLs, 1 KVL, where we're gonna start here, and we're gonna go down to the bottom to determine the drain to source voltage. And it says that the DD voltage minus the voltage drop, because we know the current is flowing downwards, and RD minus the voltage drop DS minus the voltage drop in the source current minus SS, the voltage source SS, equals 0. Now we are looking for the voltage DS. So what we do is that we solve for it. So we are left with the voltage source D, the voltage drop here, and the voltage drop here, and this other voltage source. And we substitute. We know that the voltage DD is 8. We know that the resistor RD is 20 kilos. Scientific notation. Times 0.3 milli. Minus 10 kilo times 0.3 milli minus 4 equals VS. We plug that into our calculator and we will get 3 volts. So we know that the voltage from the drain to the source That voltage drop is 3 volts. We start with our next KVL, and our next KVL is going to be right here. And we're going to start by VGG. Something interesting here is that no current is flowing through here, so there isn't a voltage drop here. Well, we can actually put it, and we could say negative IG times RG minus VGS minus RS ID minus VSS equals 0. We solve for VGS, and we start substituting. We know VGG is 2.5. We know the current in IG is 0 times 1,000 K, which is 1 mega. That will be 0. And 10K times 0.3 ohms. 0.3 ohms, milliohms, minus 4 equals VGS. So this is 2.5 minus 4. VGS is 3.5 volts. Okay, and last but not least, we're gonna do a KBL. Starting here and ending that ground. And we start saying that VDD minus the voltage drop in RD times the current that's flowing through there minus VDG plus, because we know this current, even though it's 0, is flowing in this direction, IG times RG, and here we have a plus minus, so it's a voltage drop minus VGG, that equals 0. We solve for the voltage that we are looking for, which is VDG. VDD, we said it was 8. RD, 20 times 0.3 plus 0 times 1,000 minus 2.5. Sorry. We plug all that into our calculator and we get something It's totally wrong. We get that the drain to gate voltage is equal to negative 0.5 volts. And that is one of the ways that you could find these three voltages. In our next tutorial, our next video, I'll explain the other way you can find them.